All right, combined gas law. Combined gas law. Well, by definition, what it is, first of all, we are on page 7 now in your packets, is it takes the gas laws and put them together. So, the cool thing is, let's say you can't remember Charles' law, you can't remember Gay-Lussac's law, you can't remember Boyle's law, just remember this one, and you'll have them all. What it is this. P1, V1 over T1, or P initial, V initial, T initial, equals P final, V final over T final, or 2, 2, and 2, which is what I prefer. It does not matter, okay? Now, here's the cool thing about this, you ready? If you remember this law, then you've got them all, because let's say I give you two pressures and 2 volumes, or actually check that. I give you 2 pressures, I give you 1 volume and ask you for the other one, but I don't mention temperature at all. Well, if you get rid of that, you end up with Boyle's law, don't you? Right? Or, how about this, right? If I give you a volume and 2 temperatures, ask you another volume, but I never mention pressure. Well, you get rid of the P's, and you're left with Charles' law. And likewise, obviously, just to be thorough, the last example is also true. Let's say I gave you, a pressure, 2 temperatures, and asked you for the other pressure. Well, get rid of the volumes, right? Because we never mentioned anything about volume, or that it stayed the same. If it stays constant, then you can just assume this, Gay-Lussac's law. So, cool law, the combined gas law, because it takes the 2 laws and puts them together. So, we have some problems on page 7. Let's go ahead and do them. So, number 1. Number 1 reads, if I initially have 4 liters of a gas. So, liters. Oh, a couple of things also. Right? Units, max still. They must. And temperatures in Kelvin. Why? Because it's a combined gas law, and those things have applied. Alright, so if I initially have 4 liters of a gas, that's a volume, at a pressure of 1.1 atms. So you have 1.1 atm as pressure 1, times the volume, which we just said is 4.0 liters, equals... What will be the volume if I increase the pressure to 3.4 atms? So, a new pressure wants to know a new volume. Never makes a mention about temperature, ever. So, I don't have to put anything for temperature. All this does is becomes a Boyle's law problem. You solve it for volume. 2 sig figs, 2 sig figs, 2 sig figs. Alright, so you do the math on this, and you get 1.3. Now, units must match. So volume was liters here, therefore liters, liters. How about number 2? Number 2 says, a toy balloon has an internal pressure of 1.05 atms and a volume of 5 liters. So 1.05 atms and a volume of 5.00 liters. 3 sig figs, equals, let's see if there's a temperature. If the temperature where the balloon is released is 20 degrees Celsius, so that becomes 293.15 Kelvin. That's equal to, what will happen to the volume, so you're going to ask the V on this side, when the balloon rises to an altitude where the pressure is 0.65 atm and the temperature is negative 15 degrees Celsius. Well, that's 258.15 Kelvin. You do all the math here. So I would take 1.05 times 5 divided by 293.5. I'd multiply both sides by 258.15 and I'd divide by 0.65. Okay, so that's how I would do the math there. And when you do the math, volume equals 3 sig figs, 3 sig figs, 2 sig figs. That's your determiner right there. So your answer can only have two figures, 7.1 liters. Again, I don't have all the algebra on my sheet. I do it in my calculator. But again, I would do all the math here. Then I would multiply both sides by 258.15, right? And then that would give you a number equal to 0.65 times volume. I divide both sides by 0.65 to isolate the V to get 7.1 liters. That's number, and that is combined gas law. I don't think I need to do more problems. I think you'll be all right.